So a little bit about me. I have background in computer science. I studied computer science, IT, then data analytics. Then I had the researcher stay, and then I studied computer science. I work as a senior machine learning engineer at Innovation Lab of Delta Tray, and I'm also part of technical staff of the Delta Tray Sport Experience. At Delta Tray, we are doing like graphics, streaming of entertainment and sports. We own the cameras inside the venue. We have like all the pipeline of data analytics from the venues to the videos to the data. And we're working with federation leagues and mostly all the sports. You might not heard of the name itself because we're working with the businesses. I'm also glad to be a part of PyData. I've been in PyData and NumFOCUS like several times, different initiatives and conferences. I also had the honor to work with guys from Pandas, like core team. I'm a contributor of Pandas as well. So a little bit about Pandas. Here you see Pandas community is growing fast. Like this is the number of unique commits per week of the Pandas. And as you can see here, not only the code base of Panda is growing, but also the community of contributors is also growing. And this means that in Pandas, we need to have sort of a new process for governance. Things were a bit slow before. If there were like feature requests or something that had to be fixed, it was like a slow and was basically unclear how it's had to be solved. So folks from the team started to have something called proposals. So we call it Pandas Enhancement Proposals, PDEPs. This is look like PEPs in Pandas, in Pythons, if you heard about it, or some NEP in NumPy, or some other projects in PyData, like scikit-learn is using the same. So this is basically proposals that team or anyone who would like to contribute to the future are writing, and like advantages and disadvantages of the features, what's the alternative, how we can achieve it, and that's basically deciding based on a core team how to like implement it, or how to evaluate and sort of put it in a system, let's say, if it's implementation or any decision around the future. The proposals itself are not talking about decisions, they're talking about like the features themselves. So about how the proposals had to be done is basically like there is a discussion that's still around, but they're using at the moment at Pandas, we're using like voting mechanism between the core team of the Pandas. So we have maintainers, like there is like a rule base of Pandas. You can see it in the website if you want. From the point that the PDEPs established, we have like few different proposals are going on, they already landed in Pandas. So here, the rest of the talk would be about these PDEPs and how they can sort of influence the Pandas around. I hope at the end of this talk, you would get some ideas about future of Pandas, and not only about that, but also how it works and what we are thinking about, and like basically how the open source works probably. Worth to mention also, I'm using our public information here, which my colleagues in PyData Amsterdam, PyCon DE, and PyData Global, they shared. So nothing basically is like from private or something. You can find everything in online. I'll also share the slides. And so before going through the PDEPs, I'm going to show you some changes which they already landed in Pandas. The first one is about nanosecond resolution in timestamps. So far, Pandas only supports timestamps in nanosecond, we have like an integer. So if you're gonna, like, for example, like have some date like first of 1000, you cannot basically represent it because of the out of the band integer. So there were quite sort of workaround to make it able to also work with other times, like other time stamps and resolution. So right now at the Pandas 2.1, from 2 you can actually use the second, millisecond, microsecond, or nanoseconds. This is still a workaround, so something like date range might not be still supporting the non-nanosecond resolution, but everything else should work. And you can basically use it as a unit if you have like the date time. Here the default would be nanosecond. If you're going to change it, you can do it, or you can basically cast it to the different timestamp later if you want. Yeah, so this is basically an array. If you want to change it to millisecond, you can basically do so by defining the D type, and once you are working with the time series of the pandas, or series or data frame. The other one, which is already landed, is consistent date timing. It's related to time again. Previously, once you had a date time like this and you wanted to work with it, sometimes they were not clear and a bit ambitious, like how ambiguous how you can like sort of represent these times. Like look at if you're looking at this example, the first one is like can be day, months, year, but the second one has to be like months, day, year. This is actually affecting like a lot of users at the moment, and this is like not really clear how the pandas works in this case. Basically, it guesses how it would be, but sometimes it's not working correctly. So the best practice is to use the format as an input, and from right now it's not working anymore. If you have the date like that, it might not work. Actually, it's still working, but it will show you the warning here, and from Pandas 3 it would not work anymore. The other big change, which is already landed in Pandas 2.2, which actually released 2 weeks ago, it's copy on write. It's not default, you should turn it on, or getting rid of the setting with copy warning. If you are a user of Pandas, you might see this error once you're working with the Pandas. Here we have like 3 columns, let's say, with different values, and we are going to select part of it with the binary selection, and in that case you might see this error. There are basically very like lengthy blog posts on internet which explains how it works. I'm here to give you an insight like how it works, and basically we'll fix it by the new PDEP. Imagine you have these 2 examples. The left one is using the view, and the right one is a copy. So if you have the like data frame 1 and 2, which 2 is a view of the 1, basically they're referring to the same block of the memory. And if you have the other examples like copy of data frame 2, they're basically referring to 2 blocks, different blocks of memories, right? And once you are changing one of these values, if it's a copy and you are mutating that, it shouldn't change the original data frame. But if you have a view, it might change also the original data frame. So that's basically an inconsistency which this proposal is going to address. And how we're going to solve it? We believe we can solve it, and that's gonna work like this. Here, if you have the first chain, so if you select first you filter out some values and then select the column based on that. This doesn't work right now. And if you do vice versa, it works because it will get the copy and then it works. Obviously, if you use the .loc, it will work as well. In a new version, and if you are if you don't care about the copy or view, or if you want to have a copy, you can basically get a copy of it and then work with it. And as I said, like this is very confusing for a lot of users and need to be also fixed. That's also basically affecting the implementation under the hood and in the core, which we have lots of this copy to just not to make sure the output of the assignment is working properly. So the new proposal says any data frame or series derived from another in any way. So if you're doing like masking, indexing, however, slicing. So behave as a copy. So behaves as a copy is not a copy, it's behave as a copy. I will say it in a second. And it means that if you change any data frame or series, it might not affect the original data frame which is derived from. So it looks simpler and more consistent. And we can actually get rid of that warning you've seen before, and we no longer use that defensive sort of copying under the hood. So here you had this. We had this example. So here, if I'm like changing something in subset here. Is df actually changing? The answer is no, because subset is a different object. So and then mutating the subset shouldn't change the df, right? And the answer would be the same regardless of how you are taking it. So this is going to be clear once you're working with data. Get rid of warning copy is basically once we have these two different chain modification. In the new version, none of them gonna work. So if you have these kind of things in Pandas 3, they don't work. At the moment, we're going to show some error if you're using any chain operations. First, it's going to be warning, and then it's going to be error. But the point is that we know it's going to affect a lot of users, but at the same time, it has lots of benefits around the core and performance. And we will get rid of all the copies. For that point, you don't also need to have the copy then. So because all the data frames and series would be the copy from now. So here, let's see a small benchmark on how it works. Let's say we have like 2 million of data in different types, like float, integer, and a string, and then we concat them into the one data frame. And we will run some like method chain, like renaming, assignment, dropping, and then resetting, and so on. It's gonna run like around 3 seconds based on like your machine. And if you opt into the copy and write in the new version of Pandas, it's gonna be 13 milliseconds. So this is like huge performance on this example. This is a bit well-crafted example because all of these methods are using copy at the moment in this version. But anyway, you will get a performance increase here. To showing what I said here, again, on an illustration, to make it more clear, once you have a copy of a data frame, each of copies is a hard reference to the different block of a memory, right? And basically, under the hood, the Pandas is not getting any copy once you are in a new version, but it actually behaves as a copy, and it will only make a copy once you are writing the things inside the data frame. So imagine here you use the reset index, so both of these data frames are like referring to the one block of memory. Till the point that you are reading, everything gonna be fine. Once you will manipulate any of these two, under the hood, you'll get the copy, and then we will refer to different blocks of memories. So from user perspective, you will see it as a copy. And one more thing, if you don't care about the copy again, so you can just assign the same data frame to the previous one. Here you will get rid of the previous data frame, which is like out of a scope, and the new data frame would be the previous data frame. And if you want to try it, it's already landed on Pandas, but it's a hidden feature, so you should turn it on like this. There are blogs from my colleagues and also the proposal. You can go and read more about it. And the other things which I'm going to refer here is about migration to PyArrow in general, and also the PDEP 10, which talks about a string. This is also landed already in Pandas. Pandas 2, I guess, from 2 until now. So far, strings which they were not type of NumPy till NumPy 2, which is actually already merged with the new version of 2.2.2 of Pandas. If we are using the NumPy string right now. And working with the strings was a bit like not easy and very slow. And from that point, folks from the other team try to sort of integrate the things and trying to migrate to Arrow. Here, I'm not going to the details of Arrow itself, but I'm just going to give you a glance of how Arrow itself works. Arrow is like basically a specification of defining a common sort of language like for in-memory format. So imagine we have different type of implementation in different languages. So you're going to use the data from Python to your C++ implementation. In this case, you should basically convert your like memory representation, probably like save it somewhere and then loading it again. So basically, you should get the copy and convert it to your data. What Arrow says is the common language of this representation. So everything's in a block of the memory would be the same. You would have different metadata on top of it, which shows how this data is stored already. So you don't need to basically copy it. You will just like sort of load it based on the same standard. And a lot of like PyData libraries right now using the arrows, like including Polar and the rest of the things guys mentioned. So by that, we have a standard in memory definition in arrows, which probably not at the moment, but in the future will accelerate a lot of stuff around Pandas as well. So about the types of strings. So imagine we have a series of data in Pandas. If you make this series, you will see the object dtype object in the Pandas right now. We are assuming this is a string, but it's basically object. From now on, if you are creating the series, you will see the string from PyArrow. So this is an explicit dtype of PyArrow inside the Pandas. It's already landed again, but you will see it as a default soon. If you're going to use it, there is like again an option right now. As I mentioned, this is going to improve our performance here, especially once you are working with the strings. And at the same time, it has smaller memory footprints because we're not using that crazy things on a backbone, and everything's going to work with the PyArrow. Here's the PyArrow is like the Python implementation of arrow. And at the same time, there is a good thing about it, which could basically integrate with the pandas, is about that str, which all of the functions in .str at the moment works the same as PyArrow, so we didn't have to change a lot of core functions around it. Again, let's see some performance changes and comparisons. So imagine we have some strings. If we are using the length, it's gonna like make it like a bit less. This is just an like toy example. Or if you're using the start with, it's gonna make it like 10x faster. And memory footprint is half in this example. If you're gonna try it out, as I mentioned, you can just turn on the option here, or you can check the Patrick website and also the PDEP and for more information if you like. This is also not going to only change the performance of the data once you're working with it, but also once you're storing it and loading and saving it. So load CSV and JSON at the moment dispatch PyArrow's readers. PyArrow is also have the standards for computation. So you can basically have computation of kernels of PyArrow based on your computation. So it says how to also compute the data, not only how it would be in a memory. And right now, read Parquet and read ORC, if you're using those functions, they natively use the PyArrow computation. Here is a blog post, and I'll just put the summary of it here. So there is like a benchmark of reading and saving. Just in a nutshell, it says it will make it like 10 times faster if you're reading with the PyArrow. So I might skip some of these things. And as I said, we are dispatching also PyArrow's computation. So we have an interface which says how you do the computation in arrows as well. So PyArrow is an implementation of that. You have it in Rust, you have it in different languages. So once we have a series of data and we're gonna like do some computation, and once you have a PyArrow, it's basically make it faster, because here in this example, if you're going to use the unique function, it works with the string itself, which is basically the operations on top of the strings of PyArrows. This might not be a best performance you are seeing here, but that's related to the things that not all of the functions of a core at the moment use PyArrow computation. So we are still using the NumPy. From here, just for informative, for your info, it's like at the moment each column is like NumPy array, right? And once we are working with it, is everything going to be NumPy? At the time we're using a PyArrow, right? Not all of this computation at the moment works with the PyArrow, so we're going to make it faster and faster once we can migrate everything directly to PyArrow. The other things which I would like to mention here is about allocating some values to the specific place in data frame. So imagine you have a simple data frame and you are going to put floats in a specific column, or you're going to put a string. At the moment, nobody knows what will happen about the type of this data. So because that's integer, and once you're gonna like change it, there is like not clear how it's gonna work. So we believe that Panda shouldn't guess here. And in this PDEP, basically, we're going to follow the same sort of policy. And if you're doing such a thing, you will get error unless you will basically change the format first, and then you put the data directly there. You can have like data frame with different types. Doesn't matter, but you should change it first. And I guess the last things I put here to just cover everything really fast is about in-place changes. You might work with in-place. Some user thinks if you put in-place in some functions, it will make it faster, which is not true. And basically all of these in-places are, like most of them are doing nothing. Like basically these two examples are the same. And from like notation perspectives, this is also not like shorter than the original one. So probably soon we will get rid of all the in-places in Pandas, unless it works. It will do anything like fill null or something. But the rest of them gonna remove soon. This is still in discussion, but I guess it's gonna remove soon. And yeah, that's it. As I said, we had the last release like 2 weeks ago, and in January we had the release of 2.2. So we encourage everyone to update if you're a Pandas user. And copy and write, dedicated string data type are also already there. And there are some enhancements around like PyArrow ADBC driver around the supporting SQL, or there are like new functional series with this case when you can work with that as well. 2.2.2 is also supporting the new NumPy 2 release. I will share the things with you, and you can just go through the changelog by yourself. This is like really long changelog of just like put the main important things here. And the last thing is about that. Although I'm like a representative probably from the Pandas, but Pandas is like community work. I'm just one of them. Pandas, the last version had 162 people contributed to the code base. And we welcome anyone if you would like to contribute. There is a link as well. And all of the PDEPs and details are also there. So if you have any question, notes, compliments, or anything, I would be happy to reference and address. And thanks for your attention.